Classmates, this is a look at some of the advanced problems in your time value of money chapter, page 85 in the course pack. Let's review problem number 12. Problem number 12 is a problem where I am actually giving you up front the timeline. So I've actually drawn it out for you. To contrast, problem number 1 on page 84, you've got to read the problem and at that point write the timeline out. So I say problem 1 is more difficult than problem number 12 since I already have the timeline drawn out for you. Now, in this problem, we're given the cash flows out into the future, and we want to know how much we'll pay today or deposit today in order that we might make these withdrawals. Now, this is an annuity of 3 periods, as you can clearly see, but these X's here, the X's indicate that we're dealing with the exact same amount. It's just an unknown amount. So this is an annuity as well of 4 payments. Now, again, we want to account for all compounding periods and all payments. So I'll draw a chart over here, compounding periods and annuity payments, and first of all, the total for which we must account, and compounding periods 1, 2, 3, 4, 5, 6, 7, 8. There's 8 compounding periods to account for, and 1, 2, 3, 4, 5, 6, 7 annuity payments. And again, we don't know the amount of these annuity payments, but we do know they are annuity payments. Now, again, what you need to be thinking in terms of, really for these types of problems, get your formula sheet out, because you're going to be using it very carefully. Now, you have to make some choices, either beginning setting, ending setting, because you know what your calculator does in a beginning or ending setting. So also this, remember back to your algebra classes in high school where you had unknowns to solve for. It's kind of like that, but in this case you have known values and unknown values. So you have to work with the known values first to move to the unknown values. That's the idea. So in this problem, I have 3 payments, and I want to find the present value of those payments. Why? Because I want to know the amount of those payments such that I can use that amount in calculating the future value of these payments. For example, at time 5, I am given 3 payments in 1, 2, 3 compounding periods. So this amount that I will calculate at time 5, this amount will be at a 10% discount rate, the present value of these cash flows, and it will also be the future value of these cash flows, the future value of this unknown annuity. So now I've got something started. Now I've got a present value of a known series of cash flows. When I calculate this amount will be the future value of this unknown annuity. So that gives me a place to start. And in step number 1, I'm going to account for 3 annuity payments and 3 compounding periods. So here I go in the financial calculator with an ending setting, because I'm dealing with present value of an annuity, ending setting because I'm accounting for the same number of compounding periods as payments. Notice that this ending setting and this definition here shows me exactly the point on the timeline where I need to discount these cash flows. I'm discounting 3 payments, 1, 2, 3 compounding periods. I know exactly the point in time where I need to draw my arrow, indicating where I have discounting those cash flows. So when inputting 2,000 into the calculator for payment, 0 FV because we don't have an extra amount out here at time period 8, also indicating that we have 0 left in the account immediately after the last of these 3 withdrawals. 10I 3N compute PV, and that is 4973.70. This amount, 4973.70, is the present value of these 3 cash flows. It is the future value of this unknown annuity of 4 payments. Now, at this point, what I have to do is say this. I got an annuity of 4 payments, and I have 1, 2, 3, 4, 5 compounding periods for which to account. So I know that I have the future value of the of the annuity. That amount is 4973.70. So I look up here to future value of an annuity, knowing that amount of 4973.70, and I had 4 payments and 5 compounding periods, and I don't have a formula setting that accounts for 1 more compounding period than payment. So what I have to do is I have to take an extra step to adjust my timeline such that I can then use on my subsequent step one of these 2 settings to solve the problem, solve for the unknown payment. So I choose to recognize that annuity of 4 payments as a situation for future value of an annuity where I have 1 less compounding period than payment. So I choose to discount this cash flow back to time 3. Now, let's count. 1, 2, 3, 4 payments, 1, 2, 3 compounding periods. So again, notice how the formula sheet helps you to mark on your timeline the exact point in time where you're moving the cash flows. Now, well, to get there, to move to there, I have to discount the 4973 back 2 compounding periods. So in my next step over here, step number 2, I will account for 2 compounding periods in 0 annuity payments. So I'll calculate this amount at this time. 4973.70 is FV, 0 payment, 2N, because 2 is the number of compounding periods, 10I compute PV, and that's 4110.49. Okay, now this amount is the future value of this unknown annuity at time 5. This amount, 4110.49, is the future value of this unknown annuity, but at time 3, where I have 4 payments and 1, 2, 3 more compounding periods for which to account. Therefore, I have thought ahead and I have set up the problem such that I could use an ending setting for 1 less compounding period than payment with a future value of an annuity problem. And again, the reason at this point why I'm using future value of an annuity is because I'm given the future value of the annuity. So I've set up my problem, 4 payments, 3 compounding periods. So now I can use that ending setting to solve for the unknown payment. And finally, in step number 3, that's 8 minus 5 is 3 compounding periods to account for. 1, 2, 3. And 7 minus 3 is 4 annuity payments. 1, 2, 3, 4. So let's solve for the unknown. 4110.49 is FV. with an ending setting 4N 10I 0PV, because we don't have an extra amount out here at time 0, we enter 0 for PV. Compute the payment. And there's your payment answer. X is $885.69. And that's the answer to problem 12 on page 85. Now here's what you need to do. You need to take this problem and a clean piece of paper and work it differently. You need to, I suggest, work this entire problem handling both of these annuities on a beginning setting. You'll, again, I require that you draw out this table where you account for the compounding periods as well as annuity payments, and particularly I require that you draw out the timeline. And by all means, keep your formula sheet out so you will be appropriately moving the cash flows around in time. Keep this formula sheet out. And that's all for problem 12.